All right, let's work some homework problems. Okay, we are going to work, let's get back to white here. We are going to work section 6-5. We're going to work problems 14 through 35. And I'm going to work at least one from each section just to make sure that you can get going on these. Okay, so this is the homework assignment. This will be in Google Classroom. And let's start with number 14. And if you look, number 14 is I have log base 5 of 2/3. And they say use the properties of logarithms to expand each expression. So we're going to expand the expression. Okay, so what we have here is we have a logarithm of a quotient. So using our log properties, this would be the logarithm of quotient property. And the way this works is we can rewrite this logarithm as log 5 of 2 minus log 5 of 3. Okay, and they're starting us out by expanding them. Oftentimes we are going the other way, but this would be our answer here. This is all we have to do for this problem is this one. Let's go ahead and work 15 because that one has a little bit harder. So problem number 15, this one we're given log base 6, and we've got a lot going on here. We have 2m to the 5th n to the 3rd. And they want us to expand this. Well, I have three products here. You can think of it as 2 times m to the 5th times n to the 3rd. So I can actually break this into 3 logarithms. So we're going to use our properties, and this one is property of a product. So here, this is the same thing as log 6 of 2 plus log 6 of m to the 5th plus log 6 of n to the 3rd. Okay, now we're going to use some of these properties of logarithms to do some of the homework. So this is homework 6 dash, it's section 6-5, 6-5. Let's see, that's page 319. And we are going to do problems 14 through 35. So these will go pretty quick once you get going. So 14 through 35. Okay, and I'm going to work a couple problems from each section just to make sure that you can get started on these. So let's just start with number 14. And this is, they give us log base 5 of 2/3. And what they're asking for in this section, it says use the properties of logarithms to expand each expression. Well, here we're going to use, we have a quotient. So if you look over here on our property sheet, we have a logarithm of a quotient. So it's like this one here. Erase that so we can see it. So it's this one here. And we're just going to use that to expand this logarithm here. So if we just follow the pattern, that red is really obnoxious. Let's go log 5 of 2 minus log 5 of 3. So these two things are equal. this equals, these two things are equal. Okay, now oftentimes they're having us starting by expanding. I wish they had us starting by going the other way, because usually what you're trying to do is simplify things. So usually we'll have something like this, and then we're trying to make it smaller or more simple. But we're just using this property, x over y, 2 over 3. So it's and the base has to be the same. Okay, that's number 14. Let's work number 15. That's a little bit more involved, and it'll get us going a little bit. Sorry if my voice isn't holding out so great. Okay, 15. Okay, we have this logarithm, log base 6, and we have 2 m to the 5th and n to the 3rd. Okay, and they want us to expand this. So I'm going to use my logarithm of a product here, number 2. Logarithm of a product, because here in this problem they've given me, I actually have, right? I've got 3 products here. So this is the same thing as saying log 6, I'm going to expand it, of 2 plus log 6 of m to the 5th plus log 6 of n to the 3rd. Okay, so that's nice and expanded, but they're actually going to want us to take another step here, because we can use our logarithm of a power property, property number 4 over here on the left, and we can use that to, hey, move this 5 out front and this 3 out front. So I'm going to do that, and then this is going to become, get back to white here, equals log 6 of 2 plus 5 times log 6 of m plus 3 log 6 of n. Okay, so that's how we expanded number 15. These two things are the same thing. This whole thing here is the same thing as what we started with here. And again, usually you're going the other way. In math, usually we're trying to simplify things, but they're just trying to show us both sides here of. So usually we would go simplified to something like this, but not always. It just depends on what your goals are and what kind of problems that you're working. Okay, let's work a few more problems. Let's jump down to number 18, because we want to work a few from each section here. Okay, so let's look at number 18. Oops, let's get back to a regular pen here and go back to white. So number 18, we have 9 ln of x minus 6 ln of y. I'm going to put parens here, even though they didn't in the book. And so here they want us to write this as a single logarithm. Well, you won't usually do this. I'm just going to write this out. I just want to show you something real quick. This is the same thing as saying 9 log e of x minus 6 log e of y. And I just want to point this out because we don't usually write logs with the base of Euler's number or base e this way. We use base e so much that it has its own notation, and we call it the natural logarithm. So we would say this as ln. This would be the same, 9 ln of x minus 6 ln of y. And usually these are written in cursive, although the book uses, it just prints them as ln. But in most books, you'll see it written in cursive, the natural logarithm. Okay, so this is our problem. We have this here. Let's get rid of this stuff. And we have, rewrite that a little nicer. So we have 9 ln of x here. Okay, and we want to write this as a single logarithm. Well, we have a minus sign here. And if you look on your property sheet, then that is the same. That is where we want to use logarithm of a quotient because we have a minus sign. So if we're looking at our sheet here, if we look at this side when we have a minus sign, that's going to give us a quotient. So let's get back to our problem here. So this is going to be the same thing. Let's do one first step. Before we start converting, we've got these numbers out front that we need to get those inside the logarithms before we start combining the logarithms. So we're going to say this is the same thing as ln of x to the 9th minus ln of y to the 6th. Okay, and this, that's our product. That's our logarithm of a power. So property number 4 here. Okay, and we use that to get everything inside of our parentheses because now everything's inside of our parentheses. So now we can say ln of x to the 9th over y to the 6th. Okay, and this is more of what we're usually doing, is we're taking something that's kind of complicated and with several terms, and we put it into something nice and concise like this. Okay, let's go ahead and let's jump down and work number 22. That looks like a good one to work. So number 22 is we have 8 log 3 of 2 plus 5 log 3 of c. Even my eyes aren't doing great today, guys. 7 log 3 of d. Okay. I'm going to go ahead and put parentheses here, even though they don't in your book. Okay, so we want to combine this. Well, to use any of our properties, first thing we need to do is get rid of these leading coefficients. So we're going to move those into our parentheses using our log power property. So that first thing we would do is this is log 3 of 2 to the 8th plus log 3c to the 5th plus log 3d to the 7th. Okay, and now I have plus signs here, so this is really nice. So I can use my logarithm of product property, and so this is just going to be log 3 of 2 to the 8th times c to the 5th times d to the 7th. And this would be your answer. They might, in your book answer, I wouldn't be surprised if they figure out what 2 to the 8th is. I think that might be 256, something like that. But if you leave it as 2 to the 8th, that's good for me. Okay, couple more problems. On problem number 24. This is going to be a really great problem. We want to, problem number 24. And you guys were asking me about this when we were first talking about logarithms. How do I figure out a logarithm on my calculator? And your calculators, some of the fancier calculators can do logs to any base, but a lot of them don't. And if I have something like this, well, I only have my calculator only does base 10 logarithms. So I can use my change of base property to rewrite this to where I can solve this on my calculator. And so the way this works is I can say this is the same thing as log 10 of 9. So I've just changed my base from 4 to 10. And to do that, all I have to do is divide by log 10 of 4. So this number, the 4, comes down to here. Now you might be asking, why does this work? And I'll show you a proof of this when I'm back in class and we can talk about it in person on the whiteboard. But and Khan Academy has some great videos to show you where this property comes from. But it's really powerful because you can absolutely, your calculator will do both of these. It will do this one and it will do this one. So you just have to do an extra step. But if you put this into your calculator, and again, we don't write the log 10. So in your calculator, you'll just do log of 9, right? We don't have, if we don't write the 10, then that 10 is assumed over log of 4. And then if you put that into your calculator, let me do mine here. So if I do log of 9, I get 0.9542, and the log of 4 is 0.0601. And so we are going to calculate that, and we should get something that, so that should equal something like 1.585. And we're going to make that approximately equal. Okay, so even though we don't have a log base 4 button on our calculator, we do have a log 10, and we can use this change of base property to solve the problem. Let's do another one of those because this is really a powerful property. Let's do number 25. And we have log base 6 of 5. Well, that is the same, folks, as log 10 of 5 divided by log 10 of 6. And so, again, we won't write the 10. And just doing that to just be really explicit what's going on here. And that should give us something about 0.898 is what I'm getting on my calculator. Okay. Now let's do a couple more. Let's do problem 30. And this is a different section. So they want us to use the change of base formula to solve each equation for x. So we have 3 to the x equals 4. Well, hey, this is a really good problem. 3 to what power equals 4? Well, 3 to the 1 equals 3. 3 to the 2 equals 9. So we don't really know what x is, so we're going to use our logarithms, and we're going to rewrite this. So that's the same thing as saying log base 3 of 4 equals x. I've just rewritten this exponential equation as a logarithm. And now I want to solve for x. Well, I don't know. My calculator won't give me log base 3 of 4, but I can use my change of base property. So x, I'm just going to reverse these. So I'm going to write this in 2 steps. You don't have to do this, but that's the same thing. X equals log 3 of 4. I just switched these x and log 3 of 4, switch them left to right. And I can rewrite this as log 10 of 4 divided by log 10 of 3. And so then I can get my answer just putting that into your calculator. Again, you won't have these subscripts. The 10 is implied. And so I'll get the answer. And after my calculator, the answer comes out to be approximately, let's call it 1.262, which makes sense, right? Because we know it's got to be bigger than 1, because 3 to the 1 equals 3, and 3 to the 2 equals 9, so it's going to be somewhere between 1 and 2. So 3 to the 1.262 is approximately 4. So we can use this change of base property and our calculators to work these problems. Okay, that should get you through what you need to do your homework. Be nice to your sub, and as I know you are, and as always, do the work and the answers will come. Hopefully I'll see you guys Friday, if not on Monday. You guys take care of yourselves.